This video, you're going to learn about a velocity time graph. This is your question. Okay, let's look at what the question is talking about. It said a car traveling at a constant speed of 30 meters per second for 20 seconds was suddenly decelerated when the driver sighted a pothole. A pothole. You see the pothole. It took the driver 6 seconds to get to the pothole with a reduced speed of 80 meters per second. He maintained the steady speed for another 10 seconds to cross the pothole. The brakes were then applied and the car came to rest 5 seconds later. So the car came to rest 5 seconds later. Lesson number 1, draw the velocity time graph of the journey. So I'm going to show you everything you need about this stuff today. So now you want to draw the VT graph of the journey. And number 2, you want to calculate the deceleration during the last 5 seconds of the journey. And number 3, calculate the total distance covered. So I'm not going to just take some values here. No, I'm not going to take some values. I'm going to draw the VT graph. So now you draw a line, just draw. This is a theory question actually. But once you know how to do it, it's not something hard. So I've drawn it. My time is automatically around there. Let me just extend this stuff here. 30 seconds. Let me show this one is my velocity. Meter per seconds. So now they said a car traveling at constant speed of 30 meters per second. Now a car that is starting at constant speed does not have acceleration. So anytime you add, let me say constant velocity, or it's the same thing as uniform velocity. Likewise for the speed, constant speed, constant uniform speed, uniform velocity. So if you have either of these, acceleration is 0, because acceleration has to deal with changing velocity. Now let's say this your velocity is not going like this, it's not going accelerating. At this point you have 30 meters per second. At this point you have 30 meters per second. So this is your final velocity here. This is your initial. Let's say it use 5 seconds here. So now acceleration is your what? V final minus initial over time. What's your V final? 30 meters. What's your initial? 30, then over 5 seconds. And that is what? 0 over 5. And that gives you 5. And that gives you 0. That's why acceleration is 0 at a constant speed. It's just going on a straight line like this. Assume the acceleration is changing like this, then the velocity is changing. Then you have something like 10 here and 20. So in this kind of acceleration, you have your what? You have your what? Your acceleration at this point, because the velocity is changing. Okay? So that's what you need to know about this stuff. So you get. So that's that one. Now let's continue. Let's draw our diagram so you know. It said the car traveling at a constant speed of 30 meters per second for 10 seconds. Now, if the question is not, if the question you have with you want to solve and it starts from rest, or it starts from rest at a uniform acceleration. This is from rest. This is your 0 axis. So it starts from rest. You start from this middle. It said it starts at a constant speed. So the constant speed is somewhere. Let's say at this side. I just pick somewhere. So it starts at a constant speed. Once you put the 30 meters per second here. Why did I put it here? Because this is my velocity time. Velocity side meter per second. So this is meter per second. Okay, so you put your velocity at the y-axis, your time at the x-axis. He said at the constant speed of 30 meters per second for what? For 20 seconds. Now, at this point of time, at this point, this car reached this point. It is now 20 seconds. So it is using this same constant velocity for 20 seconds. What then happened was suddenly decelerated. So it decelerates when the driver sighted a pothole. So this thing, it decelerates somehow. You know, this is acceleration. This is deceleration. You see? Now, when the driver sighted a pothole, it took the driver 6 seconds to get to the pothole. Now the driver decelerated like this. So let's say let's just stop here. Let's say the driver has reached the pothole. What? So it says it took the driver 6 seconds to get to the pothole. So let's trade this part. 6 seconds. So am I going to write 6 seconds here? No, I already have 20 seconds here. I will now add that 6 to this 20 seconds and get what? 26 seconds. What did they say about that one? They said to get to the pothole with a reduced speed of 18 meters per second. So as the man decelerates, the speed reduced to 18. Of course, that's what's going to happen, because if you see something and you apply brake, you are going to decrease your speed. So at this point now, as the decelerate to this point is now 18 meters per second. Let me write this 30 meters per second very well. You just write it at the top like this, so you can see it. It's at that point. Now, 6 meters per second, the car decelerate. Then I say what? It maintain the steady speed. So it's use the speed again. For what? For another 10 seconds. Can you see 10 seconds at that point? So that's what? You now use this thing again for the next what? 10 seconds. So are you going to write 10? No. Add it to this what? So what are you going to get? You get 36 seconds. So that's to that point. To cross what? To cross the portal. So you maintain the steady speed for that one to cross the portal. So when you cross the portal, the brake will then apply and the car came to rest 5 seconds down. So you then apply the brake again. So if it's applied the brake, what do you think? It's going to stop. So that's decelerating completely and then go down like this. Then it's take what? To rest. That is final velocity at the end. That's it means it's come back to 0. Then at what? 5 seconds later. So 5 seconds plus this 36, that's 41. So we are at 41 seconds. Now we have done what we have to go. This is our VT graph. We have drawn it like this. Do you see? I trace it at every time. Now we said number 2, calculate the deceleration during the last 5 hours of journey. Now the last 5 hours of journey is at this point. So that's where we want to focus. Now, don't forget your acceleration is what? V minus U over T. And the deceleration is the same thing. But how is it now different? It depends on what is your final and this is your initial. So this V is final velocity, this U is initial velocity, and this is your time. So you already know the time is 5 seconds as I said here, but you don't know what U and V is. Now, the car come to rest. Okay? Came to rest actually. At what? Came to rest. So when it came to rest, that is what? The rest is what? The final velocity. So what is now the rest now? That's what? 0 meters per second. Because at rest, it is 0 meters per second. If a car starts at uniform velocity, start from rest, the initial is 0 meters per second. It now come to rest final, as that is what? Final velocity, 0 meters per second. Now what's your initial relative to this final? You see, before the car come to rest, it is traveling at a steady speed, as they mention it here. For what? Steady speed of what? 80 meters per second. So the velocity, initial velocity before it gets this final velocity is 80 meters per second. Do you get? Now that's what? U is 80 meters per second and your time is already 5 seconds. So now input it here. That's Roman figure 2. What do you get? You get V is 0, then U is 18. The minus is from the formula. Then what? Your time is 5 seconds. Then minus 18 over 5. That will give you minus 3.6 meter per second square. The unit of acceleration is meter per second square. And that's your deceleration. The negative is in telling you that this is deceleration, not accelerating. Okay? So that's your deceleration. Now the third part that we should calculate the what? Total distance covered. Now on this graph, area under velocity time graph will give you what? Total distance covered. Area under that graph will give you what now? So now, how are you going to know the area is by identifying what area do you have? Do you have triangle? Do you have rectangle? Do you have square? Do you have like that? Okay? Now I want to calculate the total D. I'm going to show you 3 ways to get this thing, and you will get the same answer for the 3 ways. Don't worry. Same answer. So that is telling you that no matter how you view it, just view it clearly and view it right. So now, solution to the distance now. What to calculate total distance is to know to add all the area here to this point. That is, you know why? Distance consider every part you pass. Even if you bend around the way it's not concerning the distance, you are going to calculate everything. That's distance for you. Okay, so now they ask for total distance. So every part has its curve, every minute, every like that you calculate. Now don't forget, if you look like at this point to this point, you see something like what? A rectangle. If you look at this small point, you look at what? Something like what? Rectangle, triangle. If you look at this, if you look at what? Rectangle. If If you like this, it looks like what? Rectangle. This, rectangle. This, rectangle, triangle. If you look at this to this point, then like this, it will look like a what? Trapezium. You know what a trapezium is? Trapezium, we have small side, then longer side, then a height. That's a trapezium. If you see in form of this is a trapezium. If you look at this one, this is small trapezium. Look at this one like this to this point, then this one to this point, and like this, and the height. So just focus on one height here. You will see it's a bigger trapezium. It's a bigger trapezium. So you have two trapezium here, and again, if you should look again, you can say from this point to this point, that's a trapezium. From this to this, that's a rectangle. Like this, and this to this, that's a what? That's a trapezium. Now let me start from the last part. So I'm going to label this thing now. So we take this part as 1 to show you something now. As 1, we take these parts entirely here as 2, and we take this part here as 3. So we have divided into 3 now. Now let's go into it. Now your area for trapezium, it will going to be useful for you in mathematics, is half a plus b multiplied by the height. The area for triangle is half base times height. The area for rectangle is length times breadth, and the area for is it square? That is length times length. I think that's what you need for this one. you can have circle also, that is pi arc square. So now we have considered these three stuff, and we have trapezium, we have rectangle, and trapezium. Now let's do it. Solution to the first case. Now the first case is similar like trapezium. Let's bring our formula. Half, what's our a? So our a is from this point to this point. Now to know the distance here, you look at this bottom because they are parallel. So we take your distance at the bottom here. That is from 0 to 20. So that's a is 20. You see? Then what's your b? Your b is the longer side of theta trapezium. 1 to this side. Now check from the bottom, 0 to 26. So it is 0 minus 20, and that is 26. So 26. Then what's the height of this trapezium only? You see, it's from what? 18 to what? 30. Now 18 from 30 is what? 12. Then put your 12 here. Then multiply this stuff. 20 plus 26 is what? 46. 46 by half is 23, and 23 by 12 is 276. So we get the first part as 276. Let's do the second part. Second part is from this side to this, and this. Now we need length and breadth, so we take one side as length, one side as breadth. So now what's your length? Let's say this is our length, so it's up to 26 here. So here our rectangle, let's say length is what? 26. And you take the other side as the breadth, something like height like that. So this is from this side to this top, 18. Then you say what? 26 by 18 will give you what? That's to give you 468 meter. Then the third part is what? Look at this trapezium again. We are now deviating from this side. We are coming to this side. Now look at this trapezium. What's your a here? Let's put our half first in the question. 18 half. What's our a? A is what? From this side to this side. Check from this to this. That's what is parallel to it at the top. That's what? Difference of 10. So you have your 10 here. So then plus what? What's your b? Look at the longer side. From this side to this part side, that is what? You know, this part to this side is 10, and from this to this is 5, as what we did in diagram. That is what? 26 to 41 is now 15. So you have the 15 here. And what's your height respect to this one? So your height is from here to this top, or from here to this top, the same thing. So now look, what's it? From 0 to 18. You have to 18 outside, and this is 25. 25, 10 plus 15 is 25. 25 by 18 will give you 450, and 450 by half will give you 225. Now to get total distance, that's total D, add these three together. 276 plus 468 plus 225. What do you get? 276 plus what? 468 plus what? Plus 225. What do you get? You get 969 meter. You get our answer for this one. And let's do the second part. Let's try the second part. Second part, what do we say we want to do about the second part? We want to take this small one and the long one. This small trapezium and the long trapezium. Now let's do it. So the second method, you see, it's depending on how you view it. So now let's say for this first one trapezium, let's say 80 half. What's our A for the small one? It's from this point to this point. That's what? 20. What's our B? From this point to this point, that's what? 26. And what's our height? Our height is from this point to this top, that's 12. And all this, they will give us what? 276 meter. Now for the big one, let's do it. For the big one, you will see this is the A, very long to this side. So what is the length here? Come to this side, that's what? 36. 36 to this point. That's 36. So put your half in the formula. Write your 36. Then plus what? What's your B? Your B is the entire length down here. That's your what? 41. Then what's your height? The height is from either of the three here. Anyhow, they are the same thing. 18. 0 to 18. 0 to 18. 0 to 18. That's what? 18. The height. Then that's what? Half. Then 36 plus 41 by 18. 36 plus 41. You get 77 by 18. You get 1386. So 1386 divided by 2. You get 693. Okay? You get 693. Now add these two together. Total D. Because we have done everything. There's nothing left you want to do again. 276 plus 693. What do you get? You get 276 plus what? 693. You get 969 meters. So it's correlates with this one. Now let's do the splitting one. Splitting everybody into small stuff. Small thing. Now let's take this side as 1. This side as 2. This side as 3. This side as 4. This side as 5. This side as 6. You see, I'm splitting into small stuff now. Let's do it. So I will write my 1 here with red pen, so you know that we are doing 1. So what is 1? 1 look like it. 1 is a rectangle, so we use our length as brains. So let's say AR length as brains. What's our length for this one? That's something small from this side to this point. What is it? 20 seconds. So you have your 20, and your breadth is what? Is remain this side. That's what? 12. So 20 times 10 is 200. 20 times 11 is 220. 20 times 12 is 240. So that's what? 240. Then what next? So that's 240. Okay. Meter. Then to this two, you see the second one is something like a triangle. Right angle triangle. The area of the triangle is what? Do you know it? It's what? Half base times height. Half base times height. Then let me use my pen. That's 2. Then this is what? Half what? Base times height. So we have a half. What's our base? Our base for this triangle is something from here to this side, and that's what? 20 to 26. That's interval of 6. So interval of 6. Then times height. What's our height to this triangle? This is 12. On this top here. So this 12. So what is half of 6 times 12? That will give you something like 72 by 2, and that is 36. So that's what? 36 meter. And then what's our third one? So our third is what? It's number 3. It's number 3, right? So it says rectangle, so length as brains want to use. So what's our length? That's from this side to this side, 20. So let's say our length is what? 20. Our height is, or breadth is what? This is from this side to this side. That's 18. So 20 by 18 will give you what? 360. Then let's do the next 4, the third. The 4 is what? A rectangle also, from this to this, from this to this, and like this. So the length from this one is what? 6. So it's something like 6 times what? What's our height for this third one? Is 18 also. So we say 18. So 6 by 18 will give you what? 6 by 18 is giving me 108. Okay. Then let's do our 5 also. 5 is also a rectangle. That's from this point to this point, our length, and this is our height or breadth. So this is 26 by 36. That is what? 10. And the height is what? 18. That is what? 180 meter. Automatically. So right now, let's do our number 6. So once we do the number 6, we are going to add every distance together, every meter together. Now the number 6 is something like a rectangle triangle. So we take our half, because the formula for our rectangle for a triangle is what? Half base times height. What's our base for this one? 36 to 41, that is 5. And what's our height? 18 as well. So 18. Then 5 times 18 will give you what? 90. 19 by half is what? 45 meter. Now let's add all these things together. If we are going to get the same answer, then the first one is 240 here. The second one is 36. The third one is 360. The fourth is 108. The fifth is 180, and the sixth is 45. Now go ahead and plug the calculator. What do you get? 240 plus 36 plus what? So I get 969 meter. So which is telling you that no matter the way you think you pass, you're going to get the same answer. You see, you get 969 here, we get 969 here, also get 969 here. So that is telling you what you need to know. So I already tell you at constant or uniform acceleration was developed at constant or uniform velocity, the acceleration is 0. So that's what you need to know about this. And that's how you do all your velocity time graph. The first thing is to identify what they give you, draw the VT graph, and start to do it as they tell you what really happened. They said this happened, then do it as they say. You can split it into small like this, or you take it as a view. Just trace very well, trace, and that's how you do it. So you add your times consecutively. So this car used total of 41 seconds. So it's used 41 seconds to cover how many days? 969 meter. So you get 969 meter. So this car really try. So that is what everything you pass through. So that's all the distance it covers, 96 meter, and the time it used to cover all this 96 meter is 41 seconds. Although he escaped the accident by sighting the pothole, then he slowed down. So they don't need to tell you that this car is the graph is coming down, because they tell you it's decelerating. So you already know acceleration will come down because you are coming from a higher number to 0. But if you are accelerating, it is from 0 to higher number, or any place they give you. They can say the car starts at 2 meters per second. So if the car starts at 2 meters per second, don't go and start by 0. So you start from 2. Let's say 2 is here, you start by 2. So that's what you need to know about this one. Thank you very much. This is your VT graph, and this is how to do it.